All right, so I think I'm recording. Let's take a look at some of these problems from that past quiz. Um, Here it's given us a number line where it's graphed a set of numbers. It's an infinite set of numbers, so I can't list all of the numbers. It asks me to describe this set using set builder notation. In set builder notation, you'll put it in braces. You'll start out that it's the set of all x such that x is an element of the set of real numbers. And that's always going to be what you write down when you see set builder notation. And then what follows is if there's any constraints. And here the constraint is that the shaded region is between the values of -4 and +3. We can write that as a compound inequality. We exclude -4 and we include +3. All right, for interval notation. Now, there was some people that tried to write it as a union, and that would be incorrect. It is also an acceptable answer, although we did not write it like this in class. Would be if you were strictly greater than -4, intersected with, meaning and all of the numbers that are strictly greater than -4, and at the same time all of the numbers that are less than or equal to 3. But if you had a union there, that was incorrect. No one wrote it as an intersection. There was at least one person that wrote it as a union, and that was incorrect. In interval notation, that we write as smaller numbers first and larger numbers second. When it's hollow, we exclude it and we use an open parentheses. And when it's a solid dot here, it's included and we use a bracket. All right, so let's take a look. The second problem is similar to the first. It's the set of all numbers x such that x is an element of the set of real numbers. And then we have that x is strictly less than 0. Now here, I'm not going to use an intersection because you're in this interval or you're in this interval. So it needs to be a union. X strictly greater than 0. The fact that the arrowheads are close to -6 and +6 have nothing to do with the problem. The arrow is indicating that it's shaded goes on forever to the left, and some people mistook this arrow, I don't know, as a solid dot or something. They had -6 and +6 in their answers, which was incorrect. Now, there is another acceptable answer that many people put on the set builder notation. It's the set of all x such that x is an element of the set of all real numbers and x is not equal to 0. Now, that is acceptable. All right, so in interval notation, on the left-hand side, we have negative infinity to 0. Those are you can never include, you can never have a square bracket around negative infinity or positive infinity. We exclude 0. Since we have a break, we need a union, and then 0 to positive infinity. Now let's make a note. Some of the mistakes that I saw, people had x less than 0, like less than x, things that didn't make sense. You can't put that x is less than infinity because in your inequality statements it needs to be an endpoint. So you can't have infinity symbols and your inequality symbols in the same. It's not allowed. They just don't do that. So it's hard for me to remember exactly all the silly type of mistakes that you made on this, but do be careful that the symbols, the parentheses and the brackets are important. It needs to be exact. Look back at the notes, look back at homeworks, Look back at previous videos. We did plenty of them. Now here's a finite set. I don't have an equation. These are just points that are on a graph. And when you have a finite set of numbers, you can list them all. See, before, I had to use one of these other types of notation when my set was an infinite set of numbers, but here it's finite. I can list them. The domain is the set of x's. You can write them in any order. I typically just write it in the order that it's presented, which happens to be here in ascending order. But some people will rearrange it for ascending or descending. That's fine. You just cannot list more than one element in a set. Once it's in, it's in. The range is the set of y values. See that these were the set of x values for the domain. For the set of y values, you can't describe that in the interval notation, because then you'd be including, these are just single values. There's only 4 elements. If I wrote an interval notation and tried to say something like from -7 to +11, that's an infinite set of numbers, and this set only has 4 ordered pairs in it. Is this relation a function? Well, it is, because there's no repeat in the set of x's. Every x is related to exactly one y value. Sometimes you can see that better in a mapping, where if you write in one container the set of x's, and in a second container the range, the set of y values, and then -4 is related to -7, -1 is related to -1, 3 is related to 7, 5 is related to 11. So you can see that that every element in the domain corresponds to exactly one element in the range. You don't have a -4 being related to a -7 and also a -1. That would cause it to fail to be a function. So yes, this is a function. Now, instead of giving us a finite set or a one-dimensional graph, they give us a two-dimensional graph where we have x's and y's. But with the domain, we're interested only in the set of x values. So if we inspect this graph, we do not see any holes in it. It's a continuous graph. You can graph it without lifting your pencil up off the paper. There's no holes in it. There's no jumps. There's no jumps where part of the graph is on one side of a line and part of the graph is on the other. There's nothing like that. There's no jumps. It's continuous. So if we take a look at the arrows and break them up into components of y components and x components, and here we can't break this into a y component. It's just simply going to the right. So when I look for the domain, I'm looking for the set of x's. Well, from -infinity to +infinity, any point on this graph, you can find an x coordinate for any number that you'd like. Now, and remember, in interval notation, it's the smaller value comma the larger value. And here, if you look at all of the points that are here on this horizontal component, they all have one thing in common. The y coordinate is -3, and there's no point that's on the graph that has a y coordinate that's less than -3. Here's a point where the y coordinate's less than -3, but it's not on the graph. We're interested only in the points that are on the graph, and specifically for the range, the y coordinates. So the minimum value is a -3, and then it's going all the way up to +infinity. If you have a graph, it's very easy to determine whether this graph is a function or not. If it passes the vertical line test, then it's a function. It fails the vertical line test if you can find a vertical line that intersects your graph in more than one place. So no matter how hard we search, we can only, a vertical line is intersecting our graph exactly once. So yes, this is a function. Let's take a look here. We can see by inspection of the graph very easily that the domain, the set of x's, that you're sandwiched between these two values. Every point on this graph is between x equals 1 and x equals 3, including 1 and 3. You know, it looks to be like, you know, it's tangent, it's touching there. So from positive 1 to positive 3, including that, any point that you find on this graph is going to have an x coordinate that is between 1 and 3, including 1 and 3 itself. There's never going to be a point on the graph that's less than 1. There's never going to be a point on the graph that's greater than 3. The same idea can be applied to the range. It's also sandwiched between two values. You know, it has a maximum value of y equals 6, a minimum value of y equals negative 2. Any point on the graph, no matter where you put the point on this oval, the minimum y value is a negative 2, and the maximum y value is a 6. Now, although here's a vertical line that doesn't intersect my graph at all, it fails the vertical line test because all it takes is one vertical line to cross the graph in more than one place. So here's a vertical line, and in fact there's infinitely many that intersect this graph more than once, so this is not a function. So I'm going to stop the video there and then do these others separate. So I'll talk to you later.